Waves can destroy solid objects. A simple pendulum swings quietly, following its natural arc. When undisturbed, its movement is steady and predictable. Now imagine gentle pushes applied at just the right moments, each matching the pendulum's rhythm. With each timed push, the pendulum swings higher and higher, as if energy is being carefully stored and multiplied with every pass. This is resonance in action. Resonance happens when the frequency of an external force matches the natural frequency of an object. Every structure has its preferred rhythm, or natural frequency. When outside energy is delivered in sync with this rhythm, the object absorbs the energy efficiently, causing its vibrations to grow stronger, instead of fading away. In the real world, resonance can be both dramatic and catastrophic. The Tacoma Narrows Bridge, for example, began to twist and rise in violent waves in 1940 as the wind struck it at the perfect frequency. The roadbed rippled and swayed in massive arcs, the steel cables groaning under the multiplying force. Energy, instead of dispersing, accumulated with each cycle until the oscillations tore the bridge apart. The buildup occurs because every forceful push, precisely timed, adds more energy than is lost. Instead of calming down, the motion intensifies, showing how matching frequency multiplies force. Tiny Fact Studios.